Hello everyone and welcome to Module 5, Advanced Structures in Data Science Languages. So we'll be talking about some advanced data structures that are pretty important for the type of work we do here. Our agenda, we'll go over Module 5, we'll talk a bit about reading, Python, and R. And Module 5 does center on advanced data structures. In particular, in Python, we'll talk about classes and objects, and R, just objects because classes are kind of tricky. Then we'll move into Deliverable 5, which is around the application of advanced data structures, and go through the details of that. So jumping into the reading, the reading for this module centers on chapters 4 and 5 in the Python book and chapters 8, 9, and 10 in the R book. So moving into Python, classes are an important concept to understand, and it's basically a means of combining together methods and data that those methods typically interact with. The idea is to group together things that go together, such as, in this case, a circle, and the class circle simply accepts in essentially a constructor and defaults to a radius of 1 if nothing is supplied, and exposes several methods that allow you to interact with that class as an object. So you can create an instance of it, which becomes an instance of the class. You can think of that as being a cookie that was made by a cookie cutter. And then you can interact with your cookie, the thing you created, your instance of that class. And each instance is potentially containing different data. You'll notice 2 or 3 things in the code there. First, the word class and then circle, right? So that tells you the name. And then underneath of each one of them, like there's a def, which defines a function, underscore, underscore, int, underscore, underscore, and then some parameters that are passed in inside of the parentheses. That's a constructor, essentially. It's invoked at the time that the thing is created, so the time the class is being instantiated, so an instance is being created of that class. And self, because of kind of the quirks inside of Python, is very similar to like this in something like C# or C++. It's essentially a pointer unto itself. You don't supply it when you make a call to the method, but essentially the underlying framework is doing it for you, so it keeps track of which object is being involved. So that's why all the methods that you see there that are acting upon data that's stored associated with that particular instance, except in self as the first parameter. In the case of the constructor, the init function, it's defaulting the value to r equals to 1. That means if it's not present in the call, so in that case, if we say circle 42, then if it's not supplied, then it's going to default to 1. So that's basically how this all reads. And then below that, inside of the dump, you can see basically where it's being accessing the value that was assigned at the time of instantiation. So, and those are 2 distinct circles with 2 distinct self.radius values. So in a nutshell, that is classes in Python. So making it a little more up to date, basically the idea here is to merge in some data, and this is related to the module 4 and 5 kind of logic. So in module 4, and we've kind of moved past classes to a discussion of kind of that assignment. In module 4, you basically just kind of line them up based upon the days in which they started trading. So you didn't necessarily join off of a given date. Rather, you basically said the first day of trading of one stock compared it to the first day of trading of a separate stock. So not exactly ideal. So instead, what you want to do is merge together 2 data sets, essentially, based upon a column that they're common between the 2, in this case date. So you want them to align on date. So it's very similar to a join in a database, right? And the basic idea here is then you would be able to see on a given date that both of those stocks have in common what the average price was for that day and plot it. So you could actually do something meaningful as analysis goes. So back to kind of the idea of classes and functions and so on. A key concept is to try to reduce the amount of code you have, and that's where functions come to play. In this case, I've created a function called createSlice, which basically pulls out a given stock from the data set that we're working on, and pulls out basically the average for that stock based upon and the date, right? And then renames the columns to average to the friendly name. And then basically what I'm doing with that is creating 4 different data frames, right? You could do the same code independently, essentially duplicating what I'm doing inside of that slicing that we're doing, where I'm pulling out just the ones of interest. So the idea here is to utilize a function so that rather than creating a lot of the same code being duplicated across different environments, it's a single set of code, right? So a function, that means you only have to maintain that function. So if for some reason there was a mistake in that, it would be much easier to fix than to fix it in 4 different copies. So that's part of the concept. And this is that slice bit of the kind of operation that we need to do. Merging is a way of combining together data frames, and there's if you take a look at dataframe.merge underneath the pandas documentation, you can see that what it does is takes 2 data frames, merges them together in a way that's very similar to what you would do with a join. And you can control how that happens with the various types of joins that you use. So there's some various choices for how you want to join things together. Left is very much of a left outer join, or a left join. Right is a right join. An outer join ignores those things that are missing, and so it's essentially a full outer join. And then across is a Cartesian product, probably not something you're going to do much of, just as we don't do too much of it in a query in a database, because you typically result in all the things and in all the columns combined together in essentially all the various combinations. So typically speaking, not a good approach. One hint here that you'll want to keep in mind when we move to this: if you're merging things, you merge 2 data frames. So what you want to do is chain those together to merge one in A and B, say, and then add C to the product of A and B, and then D to the product of C and so on. So basically layer them on one after another so that you've merged together the various data frames. So a good idea is always to kind of verify that the work that you've done looks pretty close to being right. And one way to do that is to go grab an external source to validate it, right? So in this case, pulled up the price, granted it was probably opening or closing, of the stock. I guess it's probably the close price. So there could be some differences there, especially if there was a day with a lot of really high trading inside of the day. And so you can see there basically that the Apple graph does line up pretty well across, the Amazon graph does line up pretty well across both diagrams. They follow the same sort of shape. You've got a hump there here that basically corresponds in both. Obviously the scale's a bit different. You got a bit of a bounce down and then it shoots straight up. That's about here. This is probably some sort of an artificial impact based upon using the average rather than just looking at the close. So in general, tracks pretty closely. So does make me think that the way that I constructed it was right. Always a good idea to double check your data with something else if you can. So we talked a little bit about classes inside of Python. R has something similar, but generally speaking, one doesn't create your own class there. Part of that is because it's not really meant for the average user. It's possible to do, but if you're going to do it, you're probably going to be writing some low-level code and going through some more challenging development. It's not as easy to create your own classes as it is in Python. Also, because R is not as prevalent as it once was, I'm making the focus on Python, not to mention learning how to write classes in R would be outside the scope of this course. But if you really want to learn how to do it, there's a link that you can go to datacamp.com/community/tutorials, and then r-objects-and-classes. And it'll go through the thing you need to use. But the general pattern, and you've already probably seen it, is that Python is used for a lot of data manipulation, data cleansing, engineering, and so on. Also used for analysis, but sometimes you will see that pattern where people do a lot of the heavy kind of cleansing and so on inside of Python, create a file, and then pick it up from in R and read that file and work on it from that point on. So that approach actually, though, is also common for kind of a pipelined approach to data engineering, where you basically do a lot of the work, save it off into some format, be it a CSV or something, and then pick up from that stage on, either in the same code perhaps, but it's a way of potentially breaking down the stages into places to where you can have recovery if you so need. So if you get it to a known state, and then for some reason it's complex to run, maybe it takes a long time to do a lot of the work you're doing, saving it off in an intermediate file and then processing from that intermediate file on may make a lot of sense. So just a pattern to consider. Here's an example of doing some plotting inside of R, and plotting the foregraphs in a grid, basically using the grid.arrange and then giving it the plots, and I'm plotting one group per stock essentially, and so a reasonable graph, and it also is very easy to get it up and running in a nice looking way with some different colored lines and appropriate labels and so on, so the X and Y labels being named appropriately and in the right format. Similar concept of plotting inside of Jupyter Notebooks. Again, you can run, as you can see up here, upper right hand corner, this is an R notebook inside of Jupyter, and basically what you're doing is plotting it inside of this environment, and you can see that the results look pretty much the same. And again, it's up to you to decide if you want to use RStudio or Jupyter Notebooks running R, entirely up to you, but it is possible to do both. So just giving you some additional data points and some additional suggestions. One of the things with this field is you will find there are a multitude of ways of doing the exact same thing. So knowing different approaches can come in handy, because sometimes you face a situation where you need to address a particular problem in a way that you may not have done before. In that case, having more tools in your tool belt, so to speak, or tool bag, I guess, depending upon how you want to think about it, comes in very handy. Moving into discussion of deliverable 5. So we're back to you've got your consulting firm that you've started up, and you want to do some more complex examples in your code repository, implementing grouping, filtering, and index-based techniques on basically tabular data. You want to extend into the financial analysis world, and so you're creating an example showing the side-by-side comparison of stocks without having to manipulate the entire data structure. So basically, what you're doing is pulling out certain stocks and certain values and then kind of doing a pivot on them in order to reference stocks between each other without having to physically reconstruct the module. So you're asked to use the GAFA stock prices data set using Python. You read in the 4 stocks and the associated attributes into separate columns for each stock for a single data frame. Create an output file to be read in R, basically. Using R, you'll want to use Lattice or ggplot and create plots of the stock prices side by side. Additionally, calculate the mean and standard deviation for each stock between basically Apple, Facebook, and Amazon. Your specific deliverables are your source code, so give me your source code in a text file that likely ends in .py or .r or whatever the extension is for a notebook. Include some plots of each stock price, all the same plot, and a mean and standard deviation of the stock. The rubric for this assignment is as follows. A little bit of an eye chart, but as always, shoot for that mastery column. Do make sure that you cover off everything that is mentioned there. When it talks about significantly more error checking logic, that's basically making sure that when the data frames are loaded, that you do some analysis on them to either evaluate the quality of the data set or to cleanse it by replacing nulls, if there are any, with an appropriate value, and so on. So basically making sure that you don't just assume that it's good, but rather you assume that it's not and test as you go. Then use Python grouping function to group the data together for analysis. Again, more error checking, so handling the cases where some sanity checks along the way, maybe do something crazy like throw in some asserts, and then use the R programming function or programming language to read the data frame in, so read the file into a data frame. Append data from Apple, Facebook, and Amazon to the data frame, and then do some more statistical checking. Error checking to make sure that what you've read was right, so don't assume that it's just good. Do some checking, and then calculate in addition to min and max, and maybe throw in median and skew, or maybe some other statistical methods, whatever makes sense. Standard deviation might be another one to throw in. Use R to graph each of the stock prices using the default settings of the graphics library. Include significantly more options to customize the graphs to make them more visually appealing. So start with the defaults and then optimize or modify them to make it more visually appealing. And so with that, I've reached the end of our discussion of basically Module 5 and Deliverable 5. Again, to kind of refresh, classes and objects are about code reuse as a general sort of guideline. They are a way of combining together values with methods that interact on those values. They inherently happen. If you think about a pandas data frame, it's a perfect example of an object-oriented sort of approach, right? You have a data frame which has some data, and then you also have some methods that interact on that data. So it's a good example of it. The idea is to take it under certain circumstances when it makes sense to do so, and extend to do your own classes and your own methods on those objects as a way of both increasing the quality of your code and decreasing the quantity of your code. So less code oftentimes is good code and better code. And so with that, if you have questions, do let me know. That's what I'm here for. If you have any questions you would like me to address in this forum, send them to me in a message, email, or whatever ahead of time. I'll be glad to speak to them. Otherwise, stay safe, and we'll talk on Wednesday, and I'll be discussing online analytics environments, so things like RStudio Online, Databricks, Google's Colab offering. So an alternative, certainly after you've completed Module 1, so that if you are for some reason in a transient situation and it's difficult for you to work on things in multiple places, that it might be something to consider. Optional, obviously, but it could be valuable to you. So hopefully you'll at least, if you can't join, you'll watch the video. Let me know what you think. Otherwise, stay safe. Let me know if you have any questions. I'll talk with you again on Wednesday.